Hello, everybody, and thank you for joining us today for Vertica Unify 2021. Today's breakout session is entitled Getting the Most Out of Vertica User-Defined Extensions. I'm Jeff Healy. I lead marketing at Vertica. I'll be your host for this breakout session. Joining me today is Maciej Paliwoda from the Vertica Solution Architect team. Before we begin, I encourage you to submit questions during the virtual session. You don't have to wait, just enter your question into the Q&A box on the right-hand side of the screen. There will be a Q&A session at the end of the presentation. We'll answer as many questions as possible during that time. Any questions that we don't address, we'll do our best to answer offline. Alternatively, visit the Virtual Developer Lounge to ask additional questions and continue the conversation with our engineers and product experts after the session. And yes, this virtual session is being recorded and will be available to view on demand this week. We'll send you a notification as soon as it's ready. Please stick around to get the code to gain points to participate in our Analyze to Win competition and win prizes. Now let's get started. Over to you, Maciej.
Thank you, Jeff. And let's see what we have in agenda today. So I will start with basic concept about the UDXs. Then we will quickly look through the structure of the code for UDXs. Then I spent a couple of minutes to tell you how to deploy UDXs, and the majority will cover the best practices, recommendations that comes from our engineers. And the last couple of minutes, we will have a Q&A session. So what is UDX? UDX is the acronym for user-defined extension. Basically, it is highly extensible framework which allows external user-defined functions, parsers, filters, or data loaders to be installed onto Vertica server. This means that a routine that is written in C++ or Java or Python can be run in database as a Vertica SQL function. UDXs are stored in Vertica in object called libraries. They are best suited for the operations that are difficult to perform in SQL or that needed to be performed frequently enough that their speed is a major concern. You may think why you need UDXs in Vertica. First of all, we have over 650 functions in Vertica, but sometimes there is a specific need that is not available or cannot be addressed with the standard Vertica functions, and writing in pure SQL might be cumbersome. That is why UDX is perfect for that. On the other hand, UDXs are part of Vertica. So in fact, as you remember, Vertica acts as a MPP server, so you can take advantage of all distributed computing features, means that you can parallelize the processing and you can be very effective in terms of speed. UDXs are also perfect when you are porting SQL, for example, data warehouse migration, because it builds a kind of compatibility layer or compatibility umbrella that allows you to mimic the functions that are available in other databases. So for example, function if, which is available in MySQL, and imagine that you have a couple of hundred of scripts that are using that function. So you have two options: replace the if functions with case statement, which are available in Vertica, or write pretty easy and then simple function, user-defined extension called if, and then make all changes in only one place, not in a couple of hundred scripts in a couple of places in each of them. Also, Vertica UDXs are running the same cluster, so there is no data movement. So even some of them are running inside Vertica processes, so that can be very, very fast and efficient. On the other hand, you could use UDXs also to address non-standard sources or formats, or to extract specific information much more easily. So UDXs of the type loader can be used for that particular purpose. So there are basically 5 types of UDXs in Vertica. We'll list them and then we'll quickly go through each of them to tell you the characteristic of each of them. So we have user-defined scalar functions, user-defined transform functions, then we have user-defined aggregate functions, and we have user-defined analytic functions, and the last category is user-defined load. Let's start with the scalar functions. We usually develop user-defined scalar function to perform data manipulations that are too complex or too slow to perform using standard SQL statement or function. For each row in output, there is one corresponding row in input. Till version 10.1, scalar function could return only one single value per each row. But since version 10.1, we can return more than one value for the scalar function, but you have to use a native Vertica row data type, which allows you to return multiple values. How to call your function? Simply just type your function name in the select statement as you usually call any other SQL function. Another type of function is user-defined transform function, and it lets you transform a table of data into another table. It reads one or more arguments, treat it as a row of data, and returns 0 or more rows of data consisting of one or more columns. User-defined transform function can produce any number of rows as output. However, each row it outputs must be complete, because if you do not specify values for all the columns being returned, you will get the error. User-defined transform function have a specific subcategory called user-defined multi-phase transform function, where the transformation can be split into different steps. For example, first phase of your UDX could extract specific types of users interactions from a web server log stored in the column of the table, and subsequent phases could perform analysis on those interactions. Also, multi-phase user-defined transform functions allows you to decide where the processing should occur locally on each node or throughout the whole cluster. Each phase of the user-defined transform function is the same as traditional single-phase user-defined transform function. It receives a table as an input and generates the table as an output. Another type of function is aggregate function. Basically, is the function similar to what we have Vertica, like min, max, sum, that returns a single value for a group of rows. To use it, you simply specify a specified function name, and then you have to add a group clause. Another interesting type of functions are analytics functions that could be used for analytics of data stored in Vertica. So user-defined analytic functions must output a single value for each row of the data, and they are somehow similar to scalar function, but the fundamental difference is that in analytical function, the cursors for accessing input data and output data could be moved independently. That gives you a possibility to calculate the data based on the previous records from the same partition, to be precise, and you can create a function that has a similar behavior like lag function, or you can create a value, return value based on, for example, 3, 4, or 5 previous records. To call that type of function, you simply specify the function name, or you have to pass arguments, and then you have to add the overclose with partition and order by statement inside of it. And it's also worth to stress here that since Vertica is now supporting over 9,800 columns, those UDXs I mentioned also are able to support that relatively high number of arguments passing to the function. And I think it's a pretty interesting information. Then let's move to the last type of UDXs. Those are the load UDXs. So they are influencing how the copy statement operates. And they're consisting of 3 subtypes: UD source, UD filter, and UD parser. So source function, allowing you to process a source of data using a method that is not built as a standard method into Vertica. For example, you can write a user-defined source to access data from HTTP using a CURL, and you can read the data getting from another database through the ODBC standard or interface. While you can only put one single source statement in the copy command, as you can see in the code snippet, however, you can access from that UDX to multiple sources. On the other hand, filter function, which is the next one, allows you to manipulate data obtained from the source in various ways. So for example, the filter can process a compressed file, you can perform a kind of search and replace before the data is being loaded into Vertica. The last one, the parser function, takes a stream of bytes and passes corresponding sequence to Vertica load process, and can use user-defined parser functions to parse, for example, formats that are not understood by Vertica built-in parser. You can also play with the specific control that the built-in parser cannot supply. Now it is worth to talk about fence and unfenced types working mode for the UDXs. So fenced mode give you an extra buffer. You can say that they are working behind the fence, and most UDXs are working in that mode. Fenced mode uses a separate Zygote process. I will show you details on the next two slides. So it will use the separate Zygote process. So fenced UDXs crashes do not impact the core Vertica processes. There is, of course, a small performance impact when running UDX code in fenced mode, but on average, it should not be bigger than 10%. Fence mode is currently available for all C++ UDXs, with the exception of user-defined aggregates, and all UDXs written in Python, R, or Java must run in fenced mode, because probably, as you remember, Vertica is written in C++, so there is no option to code the library directly as a Vertica process for those languages. So in general, using a fenced mode does not affect the development of UDX, and fenced mode is enabled by default for all UDXs that are supporting that mode. On the other hand, unfenced mode run within Vertica. So they are as fast as Vertica process. And also from the operating system perspective, they have exactly the same PID. So with unfenced UDXs, you have to be very careful, because any problem, any bugs can destabilize the main Vertica process and can crash the node or even whole cluster. And in the next slide, you will see why. So fenced mode, as I mentioned, are available for C++, Python, Java, and R, but unfenced is only available for C++. So let's see how UDX in fenced mode is working. So when you call the UDX function, the initiator distributes the plan to executor. Executors are running, and then when there is a call for Vertica UDX, the Zygote process is created, and that Zygote process is loading the data in the libraries. And that process is communicated using a buffer whenever the process method is being called. So as you can see, if there is a problem, there is a crash, only Zygote process, the Vertica processes are not touched. This is completely different from the unfenced mode, when there's a need to execute a particular UDX function. As you can see, there is no additional processes together with Vertica process. So you have to be very, very disciplined when you are designing and developing and testing the UDXs that are running in unfenced mode. As I mentioned already, in case of UDXs running in fenced mode, they are running as Vertica process, so same PID. You have to handle properly all the exceptions, otherwise Linux kernel will cover it. And as it was stated before, only C++ libraries can be loaded. Only UDXs written or coded in C++ could work in unfenced mode. To summarize which type of UDX are available for which languages, you can see in this particular slide. For C++, basically you can do whatever you want. For Python, you can create scalar function, transform function, and load the filter and parsers. The least possibilities you have with R language, and Java is also pretty flexible. As it was mentioned, transform function can have a multi-phase type of UDXs, and that is why you can see that additional icon. So what is the UDX structure, and how to start coding it? So first of all, there are two main classes you have to implement when you are coding your UDX. One that is corresponding to your UDX type, and you have to inherit from that class. You can implement at least the process method in that function, and that class it's containing all the UDX logic. So this is where you implement your algorithm. Second class is called function factory, and also it has a corresponding UDX type. So there could be scalar function factory, as there is a scalar function, transform function, and so on. And the factory function defines the signature definition and parameters that could be accepted by the UDX. So basically, you can say that it covers all your metadata and describing how function will be called from SQL. Also, that function factory class creates an instance of your main class that is, coding the whole UDX. So quickly go through the classes for each type of UDXs. On the right, you can see the methods that are available in each language for the factory function. On the left, you can see the methods that are available for your UDX main function. So as I mentioned, you have to code at least process block, but if your UDX requires extra preparation, extra allocation of the variables, you can implement the setup method, but you have to also remember to properly free all the resources, and you can do it in destroy. Cancel is called whenever user try to interrupt the query. Transform function has pretty much the same structure. The only difference is that you, instead of process block, you have a process partition. As you remember, to call transform function, you have to use the over clause with partition statement inside. Analytic function are available as well. And also on the factory function, similarly as in other cases, you have the information about the prototype for that particular type of UDX, means that what arguments it's accepting, parameters, as well as the returning data types. In case of aggregate functions, those ones that are being called with the group by statement, you can see exactly the same methods that could be implemented similarly as in the previous ones, but you have three additional methods: aggregate, combine, and terminate, which are corresponding to the situation, what is happening. If we have a parallel execution, aggregate is executing and producing the partial results on each node, then combine is executed on initiator that collects data from all the executor nodes and calculates the final response, and terminate is sending data back to the client. Load functions are a little bit more sophisticated because they're adding some additional information. So with load source functions, you can prepare everything. The difference is in terms of factory function that they are not taking the attribute. They are, you can only specify the parameters. But if you want to pass additional parameters and you have information, what is the buffer size and what is the source, you have to also implement a couple of additional methods. On the other hand, if the nature of the data has a continuous, let's say, phase, you have to implement the continuous UD source. And that continuous source has a corresponding classes for parser and filter as well. In terms of parser, you can also have additional class to implement, because as you remember, Vertica can support apportioned load, and in the loader you can define if the source is applicable for the source, you can use the apportioned load. But for the parser, by the default, one process single threaded per node that is parsing the data. But if you want to speed up, you can use cooperative parse, and you can create multi-threaded processes to parallelize the parse. In that particular case, you have to implement the UD chunker class. That would be pretty much all regarding the classes for C++, Python, and Java. But for R is a slightly different approach. So imagine that we have a function, a norm that is taking only one argument and two parameters, mean and standard deviation. So what do you have to implement UDX in R? So first of all, you have to build your main function that contains code. As you can see, you can refer to data in the first data frame called X here, and in Y, you have an access to the data frame containing information about the OR parameters being passing. So the whole algorithm is coded in the main function. Then you have to define factory function. As you can see, there are similarities. So main function corresponds to the main class of the function. Factory function corresponds to the factory function classes for other languages. And then where you define what is the type of the UDXs, what are the input and output parameters, and then also you are referring to your main functions. If your UDX is taking some parameters, you have to define a parameter function, and it is in this code snippet. So you're defining the parameters name, the type, and names. And there is also one optional callback function that is being called whenever you want your UDX should return a variable number of columns as an output. Usually, in that particular case, you use a special type called any. And let's see, redefine your UDXs to support that situation. So as an output type, you specify any, and then you are adding the reference to your output callback function. And the output callback function can define your output column. This is exactly the same single column that was defined previously. But if, for example, your UDX should return 2, 3, 4, 5, depending on the parameters you're passing to your UDX, that is an excellent option. So you may think how can I pass different types and different number of input arguments, how I can write UDXs having a different signature, how I can deal with integers, string, or how I can pass even all columns, because I want to have my UDX to be very flexible. So the answer is simple. You can use two options. You can use function overloading, or you can use function polymorphism. What is the difference? The overloading is pretty easy. Basically, what you have to do is to define the factory function classes for each type of data you want to address. So for example, you need to have a factory function for strings, for integers, for dates, and so on and so on. As you can see, you specify the different columns that you are adding here to the cursor you are going to process. And then once you have it, you simply define aggregate functions in that particular case, having exactly the same name, but that is referring to a factory function that is corresponding to a particular data type. This red part of the code is corresponding to the function that is available from SQL, and this magenta one is corresponding to a factory functions that you have created for each of the data types your UDEX is going to process. And then when you call the function with different types of arguments, Vertica automatically will pick up correct UDX. So yes, you have to code a little bit more, but relatively straightforward. Polymorphism is a little bit more demanding because first of all, you have to use a special type called any, and then for the return arguments, you have to add any as a special data object column. And then you have to remember that polymorphic function can accept any number of the arguments. However, once they are passed to your UDX, they are not being checked by Vertica. So you have to manage inside your UDX how to deal with the particular type of the attribute, if the algorithm should work differently for the text data, or how it should work if you are passing a numeric data format. If you are designing your polymorphic UDX to support any as a return type, it requires you to handle that in the method called getReturnType. And please also check the documentation for which UDXs this is allowed to use the polymorphism as a return command. So another important aspect is how to add metadata to your UDXs. This is pretty important if you want to have direct information with which as Vertica SDK the UDX was created, what is the version of UDX, and so on, just to easier manage those information. Those information are being stored in the user_libraries table, and you can add those metadata for C++, R, and Java. In case of Java, you have to implement the class. But in case of C++ or R, you just simply call the function a register library, and whenever you install new library, those metadata are being added automatically, and then you have the reference which field is corresponding to which argument you are passing to register library function. So let's now look at UDX deployment. So UDX deployment process basically consists of four main steps. So you have to develop your UDX, then you have to install environment external libs on all, this is keyword, on all nodes, because if, for example, your UDX, you like in Java using external jars, you have to install that manually. And that step is extremely important if you are developing UDXs in R, which require to install additional packages for R. Once it's done, you can deploy Vertica on the particular cluster in your testing environment. Then you can debug test your UDX on that environment. Once all your tests are passed successfully, you can deploy in the production. But if not, you have to repeat, you have to try to correct all the bugs in your UDX. When you're deploying the UDX, first you have to create the library, and then run the statements corresponding to the particular function that library contains. Library can contain more than one function, and each of the function type contains corresponding create function statement, create aggregate, create analytics, create transform, and create source, and so on, as you can see. When you are defining library, you can also specify dependencies. I mentioned, for example, that in case of Java, you can specify dependencies to other jars that your UDX written in Java will use. This is the place when you are specifying those dependencies. And you have to remember the things. First, Vertica will take care of distribution, the function, the libraries across all the nodes. And also when you are adding new nodes to the cluster, that will be automatically updated with that information. However, Vertica will not take care of installation of any external components on all the nodes. So you have to do it by yourself. And here are the simple examples. So you are defining the library in R, then specifying for function, and you cannot forget about grants execute rights on those for function. Otherwise, users will not be able to use it. And the other example is taken from our ODBC loader package, allowing to get the data from remote databases via ODBC. And here are the code for deploying the source and the parser and the corresponding grant statements. Okay, so let's focus on recommendations for our UDXs. You can ask how to code UDX in Vertica. So I would say the best code is not code at all if a build function in Vertica already exists. So that leads us immediately to first best practice from generic UDX best practices. So if something is in Vertica as a standard function, don't code it because you cannot be faster than the built-in Vertica function. Also, try to not overcode. And it means that if the particular functionality is available as a standard functionality in Vertica, for example, sorting. One of my colleagues told me that he saw a situation when customer inside the UDX ran through the sorting process while you can push or delegate the task for Vertica, and that task will be definitely much more efficient. So do not overcode. Use as much Vertica functionalities, understand your Vertica architecture and possibilities when you are coding. Another one is think about the algorithm first, and then take under consideration any limitation that Vertica SDK libraries can have and how they can impact on design of the UDXs. Another best practice is pick the right UDX for the right job. Do not use a scalar function if you need to somehow refer to the previous records. The analytical user-defined extension is a much better option. Another important thing, and I'm going to cover this in a couple of minutes, properly handle nulls, parameters passing, and potential errors. The last one is extremely important for having error-prone UDX. And the last one, general best practice, is automate the whole deployment as much as possible, and I also will cover that in a second. So nulls, your data can contain nulls, and you have to remember that nulls are not numbers. So it's not the -1, 0, maximum value, or the empty string. Yes, you have to deal properly with the null data properly. And you have several options, or you can exit with error if there is a null. You can skip the nulls. You can convert the null into something else, or you can even ask Vertica to convert nulls to something before passing those arguments to UDX. There is one corresponding attributes of your UDX, and that tells you how Vertica should behave. So you can decide that, for example, Vertica returns null whenever you have a null input, which means that can save you a couple of calls if you have nulls in your data. Or you can force Vertica to call function even if there are nulls in your values. So you can decide, and understanding your data and nature of your UDX can help you optimize the code and avoid unnecessary UDX calls when you have nulls in your data. Another important aspect is how to pass the parameters. There could be two options. You call your function with the attribute column and then the constant value as another attribute, or you can call your UDX function with the argument and then use the clause using parameters and then pass the parameters value and their name. And in the first scenario in the cloud on your left side of the slide, you just half of the buffer that is being used for exchanging information between the God process, for example, and the Vertica process, you're just waiting for passing the constant value 0.5. Our recommendation is, if you have a constant value, use using parameters clause to pass that value. So when you decide to use using parameters clause, you have to implement get parameter type. We have seen that for the RUDX, and similarly you have to do it for other languages, and you have to implement that methods, and you can extract that information from object in the class based on the value you can process with your UDX. Also, what you can consider regarding the parameters, you can use the user-defined session parameters, and they can work as a global variables because they are read-write accessible from inside of your UDX. Then you have to just call or access the corresponding methods, and you can read those value. And also, once your UDX is working, you just store the new value in that particular variable. You also must be tempted, and this is what I did once when I was designing the UDX for machine learning and for scoring, and was a transform function that I wanted to pass to as an output at the input columns that I was passing to my UDX. And please do not do it, because definitely that will slow down the whole user-defined extension execution. And in my case, it was even 10 times slower when I was occupying the buffer to add the input column. It was better to use the scalar function. And then I'm referring to one of the generic best practices I was talking about. Think about some limitation of SDX in terms of designing your UDX. What you have to remember, the smaller number size of the UDX inputs arguments are, the fewer executor and side process data exchange, the round trips. That definitely will have an impact on the overall performance of your UDX. Also think about behavior of your UDX. So if your UDX is volatile, it will be called every time. However, if you define your UDX as immutable, Vertica optimizer can return a cache value of your UDX for subsequent identical rows that are being passed to your UDX, rather than call your UDX for each identical row. That allows you to save a bit of time during the execution time, and also that may have a significant impact of the overall performance of your UDX. Logging is another important aspect when you are designing. So you can pass additional information to log for the debugging or for just informative purposes. And how to do it? So in Java, C++, and Python, use srv interface.log, a method that has a similar syntax as print for a sprint function. In case of R, you can use vertica_log function, and you can prepare the statement up front and then pass to that function just to log it. Additionally, you may have a situation that, for example, you're passing incorrect arguments or incorrect parameters. Then you have an option to report an error and exit non-zero status. So in C++, you can use vt_report_error. For R, you can use stop function. And in case of Java, you have to throw UDF exception. And where you can find the logs for any UDXs that are running unfenced mode, means that are running inside Vertica process. All logging information will be stored in Vertica log file available in the catalog directory. On the other hand, for fenced mode UDXs, there is a special directory in the catalog called UDX logs, and then you will find all the information related to UDX execution in that particular log file. Also, there's a practice I find very useful. You can use additional parameter that you're passing to your UDX called debug level, for example. And based on the level value of the parameter you're passing to your UDX, you can have more granular or less granular logging approach. That is easy, and then you will find it useful. In my case, it works. Let me quickly tell you how we see the development flow. So first of all, develop your UDX logic as a standalone program. So focus on algorithm first, then design all the necessary unit tests, scripts, and automate test and deployment process. Next step is wrap the code you created that should work into UDX and add necessary UDX error handling that are required by Vertica. Then adapt your automation and deployments and testing scripts to your UDX behavior. Then test, debug, profile. Going to talk a couple of words about this later on, and against the potential memory leaks and other issues. And then if you find anything suspicious, any bugs, you have to take the corrective actions. Once everything is correct, you can start deployment on your testing environment. However, you need to remember 4 things. Start with a single node and fence mode. Do not start with the unfenced mode for the safety reason. And pay a lot of attention to potential leap dependencies. So when we need to use a particular leap as a dependent leap, also take note how to install it, how to compile it, and so on, because it will save a lot of time during the deployment on the test environment. Document the code very well, and also name the variables in meaningful way, just to be able to better understand the code, especially if you have a couple of factory functions for different functions of different UDXs. You need to also follow the same naming convention and so on, but because it will be easier to navigate later on and do some corrections in the future. And also care how you code, especially I'm referring here for any resources that you allocating and do freedom. Otherwise, you are asking yourself for trouble and instability of the whole system. Automation. I told you that it is a pretty important aspect, and usually make function is very, very helpful. So it is good practice to make script containing different sections for compilation, for deploying, also for initialization of the data for your testing. Pretty useful functionality is make dependent deps, which creates or installs any necessary dependencies for your library, especially say external jars or external packages for R. Also make tests just to start the process of unit testing, and then make clean to remove all the temporary or unnecessary file just to have a clean directory structure and delete any rubbish there when you are porting your code from developing an environment to the test environment. You can also make catalog, allowing you to quickly grab all the messages from UDX logs. Here you can see example, and that is very helpful when you need to quickly debug and read the log. Instead of switching windows, you can just run the single command and you have the necessary output. Memory is very, very important aspect because memory leaks can lead to instability. Over allocating memories could be very dangerous as well, because out of memory killer in Linux could call a Vertica process, and we would like to avoid this. So if your UDX is using or allocates extra memory, inform about this Vertica. You will see in a second how you can do it. And also be 100% sure that at the end in destroy method, you are also freeing those resources. You have to remember about 3 things: that if Vertica will decide that calling your UDX will require memory that is bigger than memory cap for the session or the max memory size for the resource pool you are running your query, Vertica will not execute that statement. If it's below those caps, it will wait until all necessary resources are available. So the query will be in queue till that time. And if there are enough resources, the query will be executed. For the memory problems and potential memory leaks, you can use various tools. What works well, especially for the C++, is the Valgrind tool that allows you to debug very, very precisely all the aspects related to memory, and not only. And also, as I mentioned, memory leaks are very dangerous and can impact Vertica stability. And see, this is the way how you can execute differently. This is the way how you inform Vertica about memory you're allocating. This is a scratch memory attribute, and in that particular case, you are setting it based on the value of the parameter you are passing to your UDX. Then in the setup function, you are just allocating that memory, and in the destroy method, you are just destroying this. So this is pretty important to remember and pay attention to this. Parallelism. Yes, you have to be aware what you can parallelize. Only associated. Remember that you cannot parallelize everything. Only associative functions could be parallelized. The parallelism in terms of user-defined function or extensions are depending on the resource pool configuration. There's execution parallelism parameter, also determined by the UDX type. And in particular, scalar function does not anything special, right? So it's executed by the executors as many threads as needed. Also, the segmentation and how data is distributed among the nodes have influence on the parallelism. In particular cases, when you set up the particular predicates, that may lead to a situation that for those predicates, all nodes are only in one particular node, so you cannot benefit from the parallelism. How you can influence the parallelism. In case of user-defined transform functions, you're defining them by creating or describing the partition in overclose. So every partition will have a separate instance of your UDX. In case of user-defined transform function, you can also have 2 additional clauses where you tell Vertica to partition by number of nodes. So basically, each node will process a partition that is stored locally on that particular node. And the partition base is also another way of defining partitions. It is pretty same what partition node is, but it's a multi-threaded. Both of those are partitioned by hash and then the segmentation criteria for your data. One of the last slides is about debugging and profiling. So in case of detailed debugging, you compile with extra switches for both Java and C++. For Python, you just need to connect to your process, and the same you can do with profiling. Last word about the upgrade, because you can face a situation then you're upgrading Vertica and what you have to do with the UDX, or you simply just create a new version of your UDX. So whenever you are doing the server version upgrade, okay, you have to remember about recompiling your UDX. Once recompile, you simply alter library. On the other hand, if you are dealing with a situation when you are upgrading your version of your UDX, you have two possible scenarios. If signature script means that you change the number and type of parameters. If not, you simply just alter the library pointing to your new version of your UDX. But if you change the signature, means that you added or remove or added some parameters, you have to drop the library and recreate everything from scratch, pointing to your new library. And what are the resources where you can find the very useful information when you are creating your user-defined extension? First of all, the documentation. There are 2 chapters when you can find the necessary information. Also, you can find examples in Vertica SDK examples directory. But what I recommend you very much is to, first of all, look at the blog of my colleague from Vertica about UDXs, debugging, profiling, and so on. You have the link here. It's on the GitHub. And also, you can find very useful information in Vertica knowledge base. There are a couple of articles how to create different types of UDXs with some scenarios and additional explanation, and I think that you will find it useful. So that's all about me and about this topic for today. And I'm waiting for any questions.
Thank you, Maciej.
Yeah, go
Can
ahead.
one join multiple tables inside of a UDX?
Yeah, I would.
Excuse me, inside of a UDX.
Yeah. I would use Vertica functionality. So I would join the tables first, produce the necessary data frame, and then pass all necessary columns as arguments, to our UDX. So this is what I mentioned. Use Vertica functionality as much as possible, because Vertica is optimized to do so, rather than developing or reinventing the wheel from the beginning.
Got it. Okay, thank you. All right, another one that came in. What is the performance difference between fenced and unfenced modes?
Yeah, so the extra communication through Zygote process adds approximately up to 10%. It varies from UDX to EDX, but you should not let's say observe more than 10 extra penalties when you're using fenced mode. However, from the safety perspective, fenced mode is much more better from the stability of the whole environment.
Got it. Okay, makes sense. Okay. Okay, here's another one. If I want to return 2 types of data, which UDX type should I use? For example, one type is nodes, another type is relationship between the nodes.
Yeah, so in the past I would use the transform function, right, and try to define and as an output column one for the data type 1 and one for the data type 2. Also now in Vertica UDX you have option to use the raw data type, which allows you to return multiple values for the scalar function as well. This is a key value, key and value per let's say data type, and allowing you to return more than one value for the scalar function.
Got it. Okay. Get some questions around languages. So I know you mentioned that Vertica is written in C++, but which language is preferred to code UDX in? Is there a certain language that you prefer?
I would say, as consultants are saying, it depends, right? Depends on the purpose of the UDX, and of course, for example, if you want to have an aggregate function, you can code it only in C++. Then in terms of speed, C++ will be definitely the fastest one. So if the speed is a concern, go with C++. Also, you need to consider in which language you feel most comfortable, or with which programming language you are feeling most comfortable with. So do not start, if you do not know, for example, Python, or you are not strong in C++, do not start to code them, because probably you will make a lot of mistakes and make the whole development process much longer. Also, you have to remember that you have to install additional libraries. Some libraries are not available for the particular language. So, for example, if I was designing the integration with third-party solution, the libraries to communicate with that third-party solution were only available in Java and R, right? But if I would recommend the one, I would recommend the C++ because of speed and ability to control multiple parameters in the memory allocation, right, from the code.
So lead with C++ if you can, familiarity, but then it depends on familiarity with the language. Totally understand. More questions around fenced mode versus unfenced mode. Just a follow-up question here. So under fenced mode, can you use more resources than under unfenced mode? What follow-up question?
By the resource, very good question. What do you mean by if I understand the question correctly, the more resources? Yes, the Zygote process takes a bit of computer resources, but it's not as much as you should pay attention for. So I would roughly say that more or less you are in general you are limited the memory and other resources available on the operating system level. So the short answer, in my opinion, is no.
Yeah, no, that's good. I think we have time for one more, and again, just to repeat myself, we'll do our best to answer these offline. We've captured all the questions, so we're going to end with one last one here, and this is: can you access/modify data the Vertica table directly from UDX code, Maciej?
No, the answer is no, you cannot, but that is why we have a stored procedure functionality available soon in one of the next releases, so then you can manipulate the tables from stored procedure.
Got it. Okay, that's all the time we have for questions, but as I mentioned, we will answer those as best as we can offline. But thank you to our audience for your great participation. A lot of questions came in. If we're unable to answer, just like I mentioned, your questions, do our best to respond directly via email. And again, our engineers will be in the developer lounge as well, so make sure you visit them. And please note that a replay of today's event and a PDF copy of the slides will be available on demand shortly. And of course, we invite you to share them with your colleagues. Again, thank you to our audience today. Don't forget to type session code in the Analyze to Win section on the event navigation panel. Note that there'll be a short message from our sponsors that I'd encourage you to stick around to catch. Please do visit the sponsor showcase. There's a lot of great technology services that really kind of extend our ecosystem. Now, this concludes this breakout session. Have a great day, and we hope you enjoy Vertica Unify 21.
Advanced off of turn number 4.